Ever wonder how AI models like ChatGPT or GPT-4 master human language? It's not just about feeding them more text, it's about how they learn. Today, we're diving into a revolutionary approach called curriculum learning, a strategy that's transforming AI training, making it faster, smarter, and more efficient. But here's the twist. This isn't just about the model's learning path. It's also about the hardware that powers it. Let's unravel how curriculum learning and cutting-edge systems like Cerebras are reshaping the future of AI. Traditional AI training is like throwing a giant puzzle into a room and hoping the model figures it out. You dump massive text, books, articles, social media, and the model tries to find patterns. But what if we could give it a roadmap instead of a random jumble? That's where curriculum learning comes in. Think of it as a personalized study plan. Start with the basics, then gradually tackle harder challenges. Imagine teaching a child to read. You don't hand them a Shakespeare play first. You start with simple words, then sentences, then paragraphs. Researchers are doing the same with AI. Instead of random data, they organize text by difficulty, letting the model build skills step by step. But how do you even define easy or hard in text? The team behind this study used 6 clever signals to measure difficulty. 1. Compression ratio, how concise the text is. 2. Lexical diversity, how varied the vocabulary is. 3. Readability scores, how easy the text is to understand. 4. Sentence length. 5. Perplexity, how predictable the text is. 6. Fertility, how many new words a sentence introduces. These metrics act like a cheat code, helping the model focus on the right challenges at the right time. Researchers tested 3 approaches. 1. Vanilla curriculum learning, sorting data from easy to hard. 2. Pacing functions, controlling how quickly difficulty increases. Think of it like a workout plan. Linear pacing adds difficulty steadily, quadratic ramps it up faster, and inverse quadratic starts easy but gets tough quickly. 3. Interleaved curricula, mixing difficulty levels throughout training, like switching between math problems of varying complexity. The results? Curriculum learning made training faster and more efficient. In the early and middle stages, models learned 3.5% better than with random data. Even more exciting, using a curriculum as a warm-up phase gave lasting benefits, like a head start before switching to random data. Why does this matter? Large language models need massive data and compute. By optimizing how data is ordered, we can train smarter, not harder. This isn't just about AI, it's about learning efficiency. Whether you're studying for an exam or building the next big model, the lesson is clear. Structure matters. But here's the other side of the story, the hardware that powers these models. Enter Cerebras, a supercharged system designed to handle massive AI models. Unlike traditional GPUs, Cerebras uses a technique called pure data parallelism, splitting work like a well-organized team. Its CS2 processors can be added during training, scaling performance up to 64 units. Think of it as a relay race where each processor passes the baton perfectly, keeping the model sprinting faster. Training AI requires storing tons of data. That's where MemoryX steps in, a giant off-wafer memory vault holding the model's brain, weights, notes, gradients, and tools, optimizer states. Then there's SwarmX, a high-speed network connecting MemoryX to all CS2s. Imagine it as a delivery system that zips model layers to each processor and gathers feedback like a relay race where everyone passes the baton flawlessly. Researchers tested Cerebras against traditional NVIDIA GPUs, training 2 0.5B models, 500 million parameters. On 10B tokens, the performance difference was less than 0.5%, basically a tie. This means the hardware doesn't skew the model's final skills, just the efficiency of training. It's like saying a chef's kitchen tools don't affect the meal's taste, just the speed of cooking. But the real magic. Curriculum learning, a technique where AI learns from simple to complex tasks. The team tested different difficulty metrics, and one stood out. Flesh reading ease, a measure of text simplicity. Using a quadratic pacing strategy, slowly ramping up difficulty, kept the model improving all the way through training, boosting accuracy by 2.5%. Even cooler, they used curriculum learning as a warm-up phase. Think of it like a sprinter stretching before a race. When they continued training after this warm-up, models using Flesh or MTLD, a metric for text complexity, outperformed the baseline by 3.2%. It's like giving the AI a head start by teaching it the basics in the most efficient way possible. So next time you see an AI doing something impressive, remember, it might have learned by following a carefully designed curriculum. And with systems like Cerebras, that learning is happening faster than ever. The future of AI isn't just about bigger models, it's about smarter, more efficient training. What do you think? Ready to see how these ideas could shape the future of AI? Let me know in the comments, because the next breakthrough might be just a question away. Thanks for watching. If you want to dive deeper into the math behind curriculum learning or explore how Cerebras is pushing hardware limits, hit the links below. Stay curious and keep learning.